thank you, Melissa. I'm really happy to be here today, of all days. So when Melissa told me about this event, I was super excited, and I only wanted to put the title "Spooky Connections" because I am going to talk about testing, but we will build up a little bit the topic until I reach there. So I'm Ixchel Ruiz. You can find her at Mastodon, LinkedIn, Twitter. I'm a Java champion. I collaborate with a lot of foundations, and I loved everything about software. As Melissa said, the human part and the technology part. That's what makes me very passionate. And Melissa didn't mention, but we actually wrote a book together, DevOps Tools for Java Developers. So we have collaborated in so many different adventures, Melissa and I, and technology is just one of those. So, haunted DevOps. And it doesn't have to be scary. And I agree, because my first thought, it was like, awesome, today of all the days. Because for me, today is the Dia de Muertos. See, I'm totally ready for it. And if you know any Mexicans, and even if you saw Coco, you know that Dead and Muertos and Halloween is not something scary. It's actually something that we appreciate, we value, we find it inspiring and good. So really scary is not. I mean, when I think about the monsters under the bed, I usually think about fluffy and cute and nice. But then I remember we're talking about software, and I was like, do we have monsters under the bed in software? And yes. And then everything rushed back into my mind. And yes. And the monsters that we have in software development are not the fluffy, cuddling, nice monsters. And some of them are not even visible. So I felt exactly like that. Like, oh my goodness, this session is not going to be so happy and flowers and candles. But let's take a look closer to our monsters. Well, there are a lot of them. And at the beginning, I thought, well, it's going to be only one or two in software development. Let's talk about our monsters. And the first monster of the day or of the night, it's going to be time. Time and numbers. And I know what you're saying. I Ixchel, for crying out loud. They are an infinite number of numbers. So, of course, this is difficult. But then our problems are even when we count to 100. Oh, yes, so we don't have actually any skills there. But anyway, let's continue. Second monster, security. And then, oh, well, I'm actually not going to go into our monsters, but I just want to let you know the gravity of the monsters that we are hiding under our bed. But do you want a little bit of details about this particular one? Well, we had 18,000 government entities affected, and most of the 500 Fortune companies and 9 federal agencies and more than 100 companies were exposed in the first attack, of the first wave of the attack. And this actually created the environment for other really important attacks. For example, in the pipeline, in the US fuel pipeline, and the Irish health service system, and more. So it was it is still a big monster under the bed. And let's talk about format measurements. Yeah. The Ariadne 5. So this was an error that cost, in that particular second, 370 millions because we had an integer overflow. So 4 satellites, 2,600 pounds of the clusters in the program, and In general, the Arachnid 5 turns into smoke on June 4, 1996. And as you see in one of the reports of this particular malfunction, it clearly says this could have been prevented if we had better testing. Let's talk about language, because language is there a lot and it's also not a very easy thing to deal. But obviously I'm talking about translations, but not only translations. Why don't we sometimes even prevent the small things like, do you want to cancel your subscription? And you will cancel and cancel. So sometimes our design, our way of managing operations, language, and intentions to our users is not the clearest one. Next monster, we were already there, usability. How much do we make our users feel welcomed and understand their different necessities? Well, for this, I didn't even show examples because if I'm honest, even my own personal site is not 100% fully accessible. And this is, there are several reasons, and most of them are going to be excuses, so no really good reasons. And the last and not the least important problem is generative AI, what the future will bring us. So there is a lot of monsters here, and by the time I only picked this because they are really fresh in my mind. These are the issues that I found day after day when I was a consultant. I was a little bit depressed, not the objective of this session. So I was, Ixchel, this was not the objective. We need to improve this particular session. And I felt exactly like that. So how do we actually improve this part? Because at this point, I was feeling already a little bit depressed. And that's not a good feeling for anybody, nor software developers, no DevOps engineers, no anybody. But then I remember this is not exactly about software development. This is more at DevOps strategy, or what our workflows. This is not flows. So at this point, we haven't decided about formats. We haven't decided about languages. We haven't decided. It's not there. Like, this is not the focus. Of course, it's part. It's part of the software development cycle. So I said to myself, well, probably here we don't have as many monsters as in software development. But again, that was not the case. And the most frequent cause for continuous integrated builds to fail is due to tests that do not pass. So again, I went back to the other side. Testing this is going to be totally important, no matter if you are a software developer engineer, or if you are a DevOps engineer, or you are in any part of this spectrum. And you know what I refer as spectrum, because in this moment about how do we build software, we are either fulfilling the roles of so many different people, or every single people has to know a little bit about the different activities and roles and operation and tasks and responsibilities of many sections of the software development cycle. So honestly, I cannot think myself as just a software developer, not only a DevOps engineer. So I'm the spectrum of all those two main job roles. So testing is really important. But again, tests are not the same. They are not created the same. And when we are thinking about creating our strategy, like how much effort do we have to put to unit testing, how much to performance testing, penetration testing, how much to our contract testing, from consumer to provider, how much into integration testing. And you will, because creating tests and test suites is expensive. Running tests, it is expensive. So when we have our set of tests, we have to balance how we execute them in the time constraints, not only time constraints that we have for executing, say, tests. So it's not only creating, maintaining the commission, but also during runtime. Are these the right tests that we should be running specifically for these operations? Are we actually modeling correctly what we should be testing? So when we want to create a good testing strategy, from the decision that we have already created, from our universe of tests, either if it's a pyramid, if it's a other kind of shape, because now we are even asking ourselves, what's the right shape for our tests? Should we have more unit tests than integration tests? Integration tests are very expensive. So that's why we don't have that many. And integration tests actually are linked to the complexity of the software or the interfaces that we have. In the past, when we had to mock a lot of services for an entire class, for a single class, we said to ourselves, this is clearly insane. It's so difficult to create a mock or a stop for it. It's going to be more expensive. So we created, or we focus our efforts in creating the unit test and the functional testing, and we said this is enough. This will give us the quality that we are looking for in our software. So this is the kind of the conversation that we will take us into the rabbit hole. And because I won't give you a percentage right now, I'll tell you, well, you have to have 60% of unit test, add a 10% of functional test, keep a 5% of integration test, but don't forget about your APIs. So add some testing there from the consumer point of view. And if you're creating your own API interfaces, create some producer kind of testing so your consumers can always download that test suite and check that your specification is still in order. So I'm not going to go in that direction. Instead, I'm going to tell you a story. And I think it's a good story. At least my skull says so. So this is a story, of course, very close to where I am right now, more or less close. And the day, it's September 19, 2008. It was Geneva, Switzerland. It actually was a very sunny day, but for the details of our story, it was not a sunny day. It was a very cloudy, sad, and cold day in that particular place in the CERN. And as you can see, there is a bluish kind of tube in front of it where it says that is the accelerating science, etc., etc. So that's actually a deep pool. And this year was amazing because finally, after so many years of building this particular international facility to investigate the God's particle, it was up and running. And it was up and running, and everything was awesome for 36 hours. And then, poof, literally, poof. So what actually happened? Well, in the first picture that the first and the second one appear very fast. But anyway, in the first picture, at your probably right, you will see how the ring is created with all these poles with these magnets. And the second picture is what happened after that moment. So after a few hours, a few days, there were several reports, what happened, why it happened, what was the problem. And turns out that, well, on the bright side, there were enough pieces to replace the damage. On the brighter side, there was only going to take 2 months to fix it. On the negative side, Well, the CERN has this incredible big building for testing purposes. So their tests were up notch. They were amazing. They would run whatever they could think on in every single segment of the depots of the ring. But this building was not big enough to hold two depots at the same time, one after the other. So what do you think they didn't test? And you're right. They didn't test the integration between the two dipoles. And this is exactly what made poof. So one of the things that the CERN learned is that they needed to test the integration between the two different ones to verify that the current was running as expected, that the helium wouldn't have peaked, and literally it wouldn't have exploded. It was so strong, the explosion, that even the brackets were inside the concrete to hold this depots were totally destroyed. So they learned, and we learned, that integration test is very, very important. But not only that, integration test, it has to be contextual. One of the most interesting parts of one session that I attended at Google was when the head of the infrastructure team was saying about how difficult it was to test. And one of the big lessons that they learned. And one of the big lessons that they learned is that we need to test according to what is going to happen in the hands of our users. I mean, it doesn't make sense that we test in the latest machines, with the latest operating systems, with the fastest networks, in the best conditions, if our users are not going to be there. We need to test very close to reality, but testing very close to reality, well, it's difficult. Why? Because it's reality. Like, that is hard. And in our case, testing very close to reality means testing very close to the components or how things are created. So let me introduce one of my most favorite tools, and it's going to be test containers. And why is test container so fantastic for me? Well, one of the reasons why integration tests is so difficult, so expensive, so that's why we try to reduce the amount, like natural. This is a natural reaction from developers, project leaders, project managers saying, like, you know what, from the things that are really, really expensive in terms of computer power, in terms of time, in terms of effort, etc., let's do the least amount of them. It was because we have so many moving parts in our current modern software creation or integration. We have databases, messaging systems, cache providers, and many other third-party services. So creating the real thing is not only very expensive, we need license, we need to run them and have them in actual good running system. So at first we were a little bit, we resisted the idea to create as many integration tests as possible because it was hard, it was difficult to maintain, it consumed a lot of resources. So test containers is very useful for me because, well, first of all, it plays nice, or you can create your own test in different languages with very good support. I mean, I'm a Java champion. Well, obviously, my first tool of choice is going to be Java. But if you're working with Go, Net, Node.js, Python, Rust, Haskell, Ruby, and Clojure, this is something that you can start using. When we start using containers and running programs and running our code in testing scenarios at the beginning, because when you create a container, you usually have to expose ports, name things, etc., etc. So running tests in containers, it was fantastic. It was only one run, probably in your development environment, because of this conflict of names and ports, etc., etc. When test containers comes into play, they actually abstract all this information. And not only that, they actually added something that I thought at the moment it was the most amazing thing ever. And that was they kill and make sure that we dispose of our resources in the right way. So even as a software developer, I didn't have to listen to my ops team telling me, Ixchel, you kill again our machines because you have so many zombies containers here that, well, you need to make sure that your tests are terminated properly. And I was like, I resorted to a bash command that will kill all hanging containers, but this was not manageable. This was not really a good thing. So when test containers created this very fitting idea of a third container that actually were overviewing the running sequence of all my tests and make sure that regardless what the exam or what the exit code of my test was, it was all going to be taken care correctly and nicely. So it actually creates and destroys the containers really nice. And this is an example of how you can create containers and test more or less. This is actually, I'm actually posting you some examples coming from the side of test containers. And I actually chose this one because I'm not going to show you the typical ones where test container shines, which is databases. And of course, databases are really complicated. And let me tell you the second thing that why I fell in love with test containers in the database containers. When I was creating my own, like with Docker Compose, what it would happen, I will actually have to wait for X amount, random, literally random amount of time until the container was set up in the right way. So obviously, random way should always create kind of a very sensation in all developers. So one of the supports that I love about test containers in the different, very specialized containers is that the health checks, the waiting strategies, it's all taken care of. So for example, when you are setting up your container, it is going to tell you, like it's going to tell your test, hey test, we are ready to go. We even have instantiated or started the database in the way that you need it for running your test. So in this case, I'm going to show you a mock test container. Actually, I'm not expecting you to read the code, so just listen to my voice. No, you can actually read it. I'm going to tell you what is happening here. So at the beginning, we are instantiating the mock container. We are actually using a mock config JSON, and you will see why I love mock and this particular example. And then later on, we are going to, in the should get album by ID, we're going to use rest assured to fake a client. And we're going to say, when I request a specific URL, then I'm going to expect it to be correct, status code 200. And in the body should include a value, which is the ID of the album ID that I'm sending, the same album ID that I'm requesting. And then in the body has to have a property called photos. Neat, isn't it? And it's very easy. So remember that part when it says, start my mock container with a JSON file? Well, this is the JSON file. And as you see, For creating this specific URL mock is as simple as this. You say, I want to create a mapping of type get that follows this pattern. This is one of the beauties of Wiremock. Wiremock can also be used with Java, but in this case, we are, or at least the people that created this example, is creating just JSON for specifying what the URL should be doing. So it's saying, I have albums 0 to 9 with photos. And then in the JSON body, in the part of the body, it's saying like, return the ID that you are sending, of course, and also create, for example, the specific URL. So now when the test container is creating a type of Wiremock container, it's actually starting this container and is going to use the JSON file to create all these mappings into the Wiremock container. And when later on in the test, in this part of the test, we are actually using it at the lowest level, we are going to return whatever we mapped in the JSON file. And for example, if later on we want to override a specific stuff for Wiremock, we only need to do that. Now, whenever somebody really asks for this particular URL, what we're going to return, it's a 500. And then there is a new or even feature for test containers, which is test containers desktop, because I had an M1 computer, Apple computer, and at the beginning we have some issues with containers in this Apple chip. So this set me back a little bit. But then when test container created this functionality, so now all the tests that I was running, they could be running on the cloud. So no longer I had this problem where I had to do magic, my own development environment. It was possible for me to continue running my tests because they were not going to be executed on a specific hardware that I didn't have enough control to solve, or there were some limitations. And so in this very, very nice example that it's on the test container side, we saw obviously test containers, we should at least give it a try to create your very meaningful, very short, very easy, readable, and reproducible tests. Also have a look at Wiremock. I have talked about Wiremock with different kind of examples, programmatically, JSON, all the capabilities, the record and replay, running it standalone, running I cannot say so much about this particular tool. And finally, rest assured, because it will create your client calls so easily. So I show you 3 or more or my test tools here, or my test projects, or my test libraries that I love so much. And they are magnificent. I cannot say more praises for them. So they are actually very, very good tools. But yeah, every tool, it is important, but it's not a silver bullet. And that's great. That's great that no tool is a single bullet, because thankfully there are not werewolves out there. So I really hope that at least you had a new view on something, either of our old monsters under the bed. And for the next project, one of the first things that you ask is, are we going to spend some budget into accessibility to make the site accessible, our project accessible? How are we're going to deal with dates and times and formats? What is our default programming? Our default language if you are creating a product that has to run international. Like these questions that have created a lot of problems in our industry, in our lives, and they continue to happen and happen again. I also hope that you had a sneak preview, or I created enough curiosity in you to try and see the new features. And that's the other important part. If you have already used containers, Mock, and rest assured, please have a look at the new feature that every single of these tools have released. Because, for example, Test Containers has created in almost half a year a new Kubernetes slide module, so you can even test your Kubernetes containers there. And masters, yeah, sometimes there can be scary, but they are also the source of inspirations to improve, and dream, and to have better solutions for the challenges ahead. And this was my session. I hope you enjoyed. This is how you can contact me at Mastodon, at Twitter, at LinkedIn to see what usually I have inside my GitHub. I love feedback. I love talking to people. How can I improve this session? Because this was the first time I gave this particular session. I mean, I don't get a lot of opportunities to talk about this particular day, and I'm so excited. So how can I improve it? What should I show? What I shouldn't show? And thank you so much.
Thank you so much, Ixchel. That was fascinating. Absolutely. Especially what you shared about the Hadron Collider. That's a place I haven't yet to visit, so on my bucket list for sure. Hopefully on a day when failures like that are not happening, of course. I actually never knew that about it, so that was interesting. One of the early things that you said in your talk, you said CI tests are the biggest cause for failures in your CI builds. And tests because of tests failing. Sorry. And it just made me laugh because I know you just recently went through a time change, right? Over there in Europe. So we're about over on the US side, we're about to go through that this weekend. And it just reminds me of a time when I had a bunch of very brittle tests that were reliant on time, and they would always fail, at particular times in the month. And I'm just remembering, stuff like that driving me absolutely insane. But what you really reminded me the most is that testing is not just a simple thing. It's not something that happens after the fact or just by somebody, a tester just sitting and banging on the keyboard. So what could help us define a better testing strategy?
Well, Melissa, I mean, sometimes we can have two problems. We either have too little tests or too many tests. Both things are possible. And for when you have too little tests, increase the number. That is easy. I mean, if you increase the things that you are testing over there, you will find errors faster. I mean, that have a test. But if you have too many, then you have even a more difficult problem to solve, because now you have to think about how to reduce them. Because usually, if we have too many tests, we have, as I said, constraints. Sometimes you cannot run every single test every single time that somebody makes a commit, or every single time that there is a merge into master, which should be the case. But sometimes the nature of the tests are really or either too expensive, require a specialized hardware or something like that. So they are really sometimes critical restrictions. So what you need to understand, or everybody should understand, that there are criteria that dictates or are attached to our test, either because of how difficult it is to run the test, how much actually helps into verify the quality and behavior of our software. And so the first thing that I can suggest any single developer and any team is create this criteria, create this matrix. What is important for us, how to understand what is not only important but necessary, and what is going to bring the most value and what is going to be the most meaningful inside our project. And from there, you start choosing the different strategies of your test. For example, you can decide, well, we will have this particular critical set of tests run once per week. But if we have this kind of changes in the code in this subsection of the paths, we will create, or we have to run this particular set of tools. If we're changing the encryption, then we have to verify this. So as you see, there has to be classification, and obviously trying to limit as much the number of tests that you are running, but keeping in mind what is meaningful and valuable. But that's only going to be answered by your own matrix of critical points and how they affect your software.
That totally makes sense. I mean, our tests need just as much care and feeding as the rest of our code base, right? We can't be sloppy with it, for sure. You've made some really good points. Well, you called out a couple tools that if you're not using them, you should be. Test containers for sure. I definitely remember being in a situation where we were using an in-memory database for everything just because it was faster. But what you just described, like there could be a suite of tests that would make sense with an in-memory database, but there are times when semantics matters, and you need to really be using the exact database that you're using in production. So test containers would have solved that issue for me years ago. That's something I recommend too, for sure. All right.
And that's exactly the point. I was just going to add something. It's no longer that expensive. So we don't need to use in-memory databases anymore because they are fast, they are easy to start, they are easy to test. So this is the beauty of these containers. You don't longer need to pay that expensive price in terms of how much it takes to start test.
That makes sense, and good to know. You're right. Things are improving all of the time.